This article is related to EEG seizure prediction using time frequency features and long short-term memory networks using MATLAB. In this article, basically, I have developed the complete electroencephalogram like EEG and signals that can be used to predict the seizures, allowing for timely interventions and we have to do the EEG based seizure prediction using the time frequency features and long short term memory networks as well. So, the epilepsy is the neurosurgical disorder that affects approximately 50 million people worldwide. So EEG data basically pre-processed and segmented into repositories and from which the time frequency feature extraction are extracted. Okay, so in this article I have also predicted that I have our approach basically evaluated on a synthetic EEG dataset, achieving the test accuracy almost 92.5% and an AUC basically of 9.97%. So, the results basically uh, demonstrate the effectiveness of the proposed approach in the predicting seizure from EEG dataset and unprovoked or reflex seizure and an probability of further seizure similar to the general recurrence at risk at least 60% after two unprovoked seizures. Okay, so we have used the main machine learning approach such as sport vector machine, random forest, and convolution neural networks accordingly abstract with the introduction, and in the introduction I have just added like how the EEG signals recorded in the electrical activity of the brain and these are the parameters comparison with the existing methods like how the accuracy, sensitivity and specificity based on the same approach. Okay, so in like the method different but the with the different kinds of approach as well. Deep learning approaches basically convolution neural network and the EEG dataset. Here is a table of patient demographics in which provide us the different age, different sex, different seizure types according to patient IDs. Okay, so the background of epilepsy, which is basically related to how the EEG signals for seizure prediction has been widely explored and how the spectrum power and entropy use. The unpredictable basically of the seizure makes it the challenge and here is a based prediction based basically using the sampling rate, epoch length, overlap uh, preictal duration basically data feature model as well as the results according to different accuracy confusion matrix plot performance plots RFC. So the proposed approach, like I have used the like SVM, sport vector machine, neural network, dataset contains patients with PLSP with the Caesar annotation. So the proposed approach achieves a high accuracy according to um, the AUC demonstration with its effectiveness in predicting the seizures as well. So significance and impact is that we need to reduce the treatment of patients and we need to reduce its its risk, and its seizure. We need to extend the real-time seizure prediction system, enabling the timely interventions and improving the patient outcomes as well. Okay. So here is the problem statement. Problem statement is same like the epilepsy is a neurological disorder characterized by recurrent seizures affecting approximately 50 million people worldwide. So that's why, despite of advances in treatment, one-third of patients with epilepsy continue to experience seizures, highlighting the need of for improved diagnosis and treatment strategy. So the uh, unpredictability of seizures basically make it challenging for the patients to engage in daily activities, causing the anxiety, depression, and social isolation. So that's why we need this approach, and we need to accurately predict the seizures and to do the EEG signals properly to save the patients. Here is a mathematical approach. These are the equations used in the mathematical terms for the MATLAB, and these are the methodology. Methodology means in which I have just added how LSTM network architecture and how its input output parameters are used. And here is the design of MATLAB simulation with the analysis. These are the EEG approach time domain, and this figure shows a spectrogram of channel time frequency feature distribution, which is basically provide us how the counting of different disorders, and these are the mean normalized features as well. Is a confusion matrix, ROC curve. So this is the basically training progress for the epoch and EEG under the curve of AUC. Okay, under the curve mean AUC representation, the model's performance, results and performance according to our main proposed EEG signals prediction and conclusion with the references as well. Let me just need to open this, and this is a MATLAB file. Okay, so you just need to run this MATLAB file. Dataset with normalized and balanced trained with the LSTM network, and ROC test with the separate plots including in it. Okay, and you will run it, you will get the output results accordingly. I think this will run in the MATLAB 2021. Basically, my MATLAB 2025 is not up to date, so that's why it cannot run few functions. So this is the MATLAB demonstration of article EEG seizure prediction using the time frequency features. Let me just explain to you how the output results generated in terms of MATLAB. It will take some time, but it will be in running condition. See, here's the training iteration according to different trainings. This is basically the loss versus accuracy according to iteration results, ROC curve, confusion matrix, mean normalized features, feature distribution, spectrogram channel, and the EEG approach time domain. Okay. If you need to ask anything, you just ask me. I will answer your questions. Thank you.